All right, we're back. This is chapter 9, CNBT 1311. Um, this chapter is called Special Construction. Guess I had to come up with some name for it. So we've got stair design, stair requirements, stair plans, wood stairs, concrete stairs, steel stairs, spiral stairs, ladders, elevators, escalators, fireplaces, fireplace requirements, masonry chimneys. Doesn't say masonry fireplaces, it says chimneys. Prefabricated fireplaces and stoves, kitchen layouts, dimensions, bathroom layout, plumbing fixtures, blah, 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 blah. There's a lot of stuff in here. There are a few subjects, bathroom and kitchens, that we could spend 3 weeks um, studying the good, the bad, and the ugly. Stairs and elevators. All right, so let's get started. But we're not going to spend 3 weeks. We don't have 3 weeks. All right, what does he call special construction? The reason he stuck that in here, these are elements that are needed. Super high-rise buildings, well, they need vertical transportation for people, and these elevators need to be high-speed elevators, and they need to be, and they're special kind of elevators. In a conventional building, doesn't have an elevator. Of course, these tall skyscrapers will also have fire stairs that go up all the way through because you're not going to use elevators in fire. Um, Residential stairs, steps, shallow ones, stoops, turns, landings, platforms, and then vertical runs. Um, so, stairs will get you sued. Um, you screw up a stair, it's hard to unscrew it. I mean, once the thing's built, the house is built, or the building's built. Um, we'll talk about that more later. Um, we'll talk about elevators, fireplaces, and wood-burning stoves, and kitchens and bathrooms to some extent. Stair design. He gives you some rules of thumb. You need to check your current building code wherever you're at for stairs. These codes change. I've got a set of Rhode Island codes from back in 2009 I'm not going to bore you with. And I guarantee you those things have been modified. They've had to have been. If you go out on D2L, in D2L, I'm not going to pull the tab over. Well, yeah, I am. What the heck? There we go. All right, in D2L right now, I've gone ahead and went through Chapter 9 and stuck Chapter 9 stuff in here. You already seen the exterior door measurements, the Genwell window install. Here's a thing on spiral stairs from a manufacturing company. Here is sort of some history on what makes it left. Why is it left and right-handed? It's kind of my little geeky thing. We'll talk about that. Rhode Island stair building, Benjamin Franklin fireplace, Benjamin Franklin stove actually. How to choose a wood stove, chimney fires. We're going to look at some really nasty flashing. I mean, ugly flashing. Now, these for elevators are very important. This is everything you ever wanted to know about elevators. Okay, this is a whole industry unto itself, and we will talk about that later on. But that's all in D2L, and they're quick reads, and we'll go through them. All right, let me pull this tab off of here and get it over in the other screen. Okay. All right. How are we doing on YouTube? Let me check that real quick. Where's the YouTube channel? There it is. All right, all the Chapter 8 videos are public. All right, so hopefully we'll get Chapter 9 out of the way, and then we'll have Chapter 10 and 11 to finish off the course. Maybe 12, we'll see. 12 is materials. If we had a face-to-face class, you would be beat up, but 12 is really, well, we'll probably go through 12. Yeah, we will, because it's got fasteners in there and stuff like that. So, yeah, we'll do 12. What the heck? 12 kind of cycles back through what we've been doing. But nonetheless, let's get into chapter 9. I'll quit prattling on. All right. Where are we at? We're right here. Ladders. A true ladder goes straight up. A step ladder is at this angle, and it talks about the 12 3/4 riser and a 3-inch tread. A typical ladder is 12-inch between the rungs going up. You need to get some definitions down, and we might as well do that right now when we talking about risers and treads. In fact, it's probably time to pull one of these up. Which one are we going to? Here it is right here. How would you like to climb that puppy? Yeah, that's a set of stairs, but really that's more a step ladder. And the author and the carpenter that did it states it was pulled out. But is in a narrow space. And in between each tread, he's got storage and drawers going all the way up. Now, obviously, this is not used for a normal traffic pattern. This is an access to a scuttle up here. So, but he did a good job. This guy's got a good video on how to actually cut and lay out stairs. So let's see here. So let's get us a definition. And this is his step stair. 1 foot and a 4-inch. He took these dimensions off of a step ladder design. All right. All right. Here's a design from a home that he carpentered up. Where's my, oh, this is not in Microsoft. This is not in Edge, so I don't have a pen tool. Oh, heck. That's why I don't do cooking shows, boys and girls. All right, this is the tread. That's your tread. That's your run. Now, there are 2 runs on a set of stairs. There's the overall run. You know what? We're going to fix this right quick. We are going to fix this right quick. There we go. There we go. Okay. This is your run, big R. This is your riser, little r. Okay. And this would be, I can't believe I almost did that vertically. This dimension is your overall run. Now, if this was a face-to-face 16-week-long course, you'd be doing stair calculations. I'd give you a house, and you'd be doing the calculations for how much room you're going to eat up. This is what I call the total run. The total run. And it matters. When we get back in the Ching book, I'll show you why it matters. Okay? But big R is the run, and it's not the tread length, because a lot of these treads, when you come in and you put the tread board on here, it'll have a nosing on there. We're talking about this right here. These are the stringers. All right? There's a ratio that you need to understand, and he talks about that in this article. If you can stay as close to 18 inches, rise over the run and rise, run plus the rise, rise plus the run, oh my God, as close to 18 inches as you can, you have a comfortable, good stair that most people can navigate. Now, children are going to have a hard time with 8-inch, but as this decreases, as the riser decreases. As this gets smaller, this has to get longer. All right. So if you can keep it as close to 18 inches as possible, this happens to be what, 17 and a quarter, 6 and 12. If you can get by with a 6 and 12 is good. Okay, 6 and 12. If you've got the room in the house to do that, okay, that equals 18 inches, right? That equals 18 inches. And then he goes on to talk about two times the riser plus the run is 25 and a quarter inches. It's almost perfect. Stairs will be comfortable. I'd stay away from this and stay in the conventional of 18 inches and try to do a 6 and 12 if you can. You certainly don't want your tread or your run to be so small that your whole foot can't get on it. But then you don't want it to be so big that, see, this is 17 and 3/4. That's 18 inches. 7 and 11, 6 and 12. Now these are shallow stair examples. All right. So this is 14 inches. So foot 2 inches, and then that's 4 inches. So the Rhode Island amended the IRC, the International Residential Code. That's what they use up there, or they did at this time when he wrote this article, to allow a maximum rise of 8 and a quarter and a minimum run of 9. Okay. Both numbers are close enough to the ideal to be comfortable for most people. Now, these links in this PDF, watch him cut where the does. So you can just go to YouTube and research a stair stringer. You use a frame and square and that sort of thing. But this is the ratio that is what we would call ideal. Trying to keep something that proportion. All right, the 6-inch riser and a 12-inch run would give you 18 inches. That extra 2 inches helps people that don't walk real well. The extra 2 inches. The 2 inches less in the riser here, if it's 6 inches, is easier to step up on, especially as people get older and children. All right, let's get back to chain. So this is in D2L, and if you're really passionate about architectural design, you're going to find these and Reasoner's YouTube channel out of Austin, and just start creating your library of ideas. Like I said, there's nothing on this planet that's holding you back but you. All right. For private stairs only, you want a 7 3/4 inch maximum riser and a 10-inch minimum tread. Now, looky here. That's 17 3/4. That's pretty close to 18 inches, right? Yeah. This is a good standard. Somewhere around 18 inches. Stairs eat up a lot of your floor space. You've got to plan it, okay? Building codes regulate the minimum and maximum dimensions of risers and treads. Exterior stairs are generally not as steep as interior stairs, especially where dangerous conditions, such as snow and ice, exist. Well, that makes sense, right? You don't want to be falling down the Mayan sacrificial stair steps from one of the Mayan pyramids trying to get out of your house. All right. Now, this is very bloody important. I've seen people lay out stairs where they change going up the flight the ratio of the rise and run just so they can cram the stair in. This is very dangerous. For safety, all your risers in a flight of stairs should be the same rise, and all treads should have the same. If not halfway up that flight that you're climbing, you're going to make the people have to change their cadence. It's very dangerous. And building codes limit the allowable variation of the riser height or tread run. All right, you have to go check your codes. Stairs they lock your design in. Once you decide where your stairs are going to be, they pretty much lock you down. You got to build around them. You screw them up, it's hard to unscrew them. All right, here's a chart. The actual riser and tread dimensions for a set of stairs are determined by dividing the total rise or floor to floor height by the desired riser height. What is he talking about here? What is he talking about? All right, here we have a set of floor, and then here's the top floor. Okay, and we got those stairs. This is what he's talking about. All right, the riser height. Okay, good God Almighty. The actual riser and tread dimensions for a set of stairs. Where are we at? The result is rounded off. Okay, the total rise. Just like I said in that other dimension, we had total run. This is total rise. The total rise from here to here. So now you got to play with the mathematics. If I'm going to use a 6-inch riser, and this is 12 feet, then I got to divide 12 feet in inches. Is the result? Good God Almighty! Wow! For a set of stairs, the total rise or floor-to-floor height by the desired riser height. The result is rounded off to arrive at a whole number of risers, and the total rise is then redivided by this whole number to arrive at the actual riser height. Okay, so what's 12 feet? That's 72 inches, right? Let's just say this is 12 feet, which is 72 inches. So we got to divide 72 by 6 inches, right? So what's 72 divided by 6? Divided by 6. Well, let's go over to the calculator. There's going to be a couple of videos. So we got 72 divided by 6. All right, that's 12. So we have 12 risers, right? Okay. You wonder why I picked 72, right? Because it's 2 and 6 is an even number and 72 is even. So it'll go in 12. So, all right. So we've got 12 risers. So if I'm going to use the ratio of little r plus big R, that's the run. All right. I want that to be 18 inches. And I use 6. Then I got 12 of these. So if this is going to be 12 inches, then I got what? 6 times 12? I got another 12 feet. Theoretically, 12 feet for my total run. So that's about a 45-degree angle, 12 and 12, right? Okay. All right. So that means I'm going to eat up 12 feet of floor space. Now, if this is an exterior wall, I got to have a landing, and a landing wide enough to get stuff turned around in the landing to get up these stairs. Now, this is NTS. I drew this, not too sure. Not to scale. How's that? Okay. All right. So that's the challenge we get into. So this riser height must be rechecked against the maximum riser height allowed by the building code. So if the building code says, okay, you can have 6-inch risers, and my floor plan allows me to eat up 12 feet for the stair run plus the landing. Let's say this is 4 feet. That would be a minimum. That means I got to have 16 feet from this point to the exterior wall in my floor plan. Somehow I got to put the stairs in, right? And this might be a little elevated platform. So then I've got to have maybe 2 stairs to get from the main floor down here to the landing to turn, then to go up the main flight. All right. And once the actual riser height is fixed, the tread run can be determined by using the riser tread proportioning formula. Since in any flight of stairs there is always one less tread than the number of risers, the total number of treads and the total run can be easily determined. There's one less tread. So if I've got 12 risers, then I'm going to have 11 treads. Okay, I'll have 11 of these. And this is theoretically a landing, and this would be your top tread up here. So you'd theoretically have 11 of these. All right, so let's move on. Does that make sense? I'm sure it does. Yeah, right. We'll be glad this isn't a face-to-face class because you'd be doing a lot of these. If it was 16 weeks, we had time. But we don't have time for that. I'm not going to make you do it. There are a lot of good videos on YouTube of architects and carpenters and how they lay this stuff out. All right, let's move on. How much time did we burn up on that prattling along? 21 minutes. Oh my gosh. Well, this is going to be a series of videos since we're dealing with stairs. All right. Stairway design is strictly regulated by your building code. For commercial buildings and residential, all right, these are cast in place concrete stairs. Most likely, if that's a smart contractor, he will come in with prefabricated metal pans, steel pans, this structural steel, and then he'll cast the concrete stairs, and the pans will be attached to the structural walls. But as you can see, each one of these flights has a landing, and then they go up, has a landing, then he goes up and has a landing. And in the face-to-face classes I taught, you had to calculate all those landings and the heights in them. And but we're not going to do that here. You need to read all of this for stair requirements. Handrails are very, very important. They're regulated, how they're terminated, how far they stick out. Let's see here, guardrails, handrails, same thing. They are required to protect the open. If not, you're going to fall through the stairwell. Like an Alfred Hitchcock movie or something. All right. Should be at least 42 inches high. And in dwellings, maybe 36 inches high. And that means in residential, maybe you need to check your building code. And then the spacing between the rails. Do you have vertical, like in a residential? How far apart are these? I guarantee you my house is not going to meet modern day code. It's grandfathered in because it's 50 years old. But the spacing between the railings would not be a modern day code. But it's grandfathered in. The occupant load. What about the stairway width? It goes back to the building code. The occupant load. Remember the occupant loading? All right. Which is base, required, and exit. You got to consult the building code for this. And we all know that the rule of thumb is this 44-inch minimum. But depending on how many people you're trying to get down these stairs in an emergency, they may have to be wider. Now, he references 36 inches for people that find a load of less than 49 people. Again, you have to check your building code. Handrails may project a maximum of 4.5 inches into the required width. Um, we're talking about the width of your stairs. That's why in my personal design from years ago, I would take this handrail projection into account for the width of the stairs. Now, I would try to argue for a 44-inch minimum, period. I don't care. Over the life cycle of the building, it's not, because you're going to lose 4.5 inches here, and you're going to lose 4.5 inches here. So that's 9 inches, right? So what's 9 from 44? Okay, that's less than 36 inches, right? So that would be like 33 inches clearance between the railings. All right, so you got to take all this into consideration, because the last thing you want is to get this stuff built and have the building inspector come in on your job and red tag this. Because remember when we talked about the shear walls in the building, where we would have a building and maybe you had a giant center elevator core, and then on the other ends of the building you would have another concrete column and maybe another one, or depending on how many people you have up here, you might have another set of fire stairs, and these would be concrete shear resistant shear walls going all the way up the building, and this is where your stairs would be, going up and down, and here, and here, and here, because during a fire you cannot use the elevators, they get locked out. So the last thing you want is to have this stuff red tagged after you've got all this cast in place. Let's talk about projections. Let's see, project at a maximum of 1.5 inches. All right. What's he talking about? Oh, that's the trim off of this. You don't want that. You don't want your escutcheons or your trim that mounts the handrails to go into that 4.5 inch space more than 1.5 inches. Any doors that swing in the direction of the egress, the door swing must not reduce the landing to less than 1/2 of its required width. Now, what's the required width of the landing? That depends on the building code, depending on the amount of people that are trying to get down those stairs. Okay, you got in here, and then you've got a total in here that's determined by your building code. All right, you don't want to reduce this. The last thing you want is people running down here because they're on a plane into that high-rise building, and then you got these people on this floor that are trying to exit, and then you got a big convolution right here, and then this allows these people to move. All right. This is probably the less prestigious but most important part of a building design. Landing should be at least as wide as the stairway, at least. In my opinion, landing should be wider than the stairway. That allows you to turn in here. Because this is a place where people are going to start bundling up. If you've got people trying to get out of this floor, well, you got people from that floor coming down, it's going to be a big mess. And you're going to be like a herd of sheep. Let's see. Straight run stairs to be longer than serving straight run stairs, landings. Measured in the direction of travel. Yeah, we already talked about that. Not be longer. Landings serving straight run stairs need not be longer. What he's talking about, if you didn't have a turnaround, let's just say we have straight run, and then here's freedom out this door. Okay, door opens, and okay, bad things are happening over here. People are exiting, running the fire stairs, and out, and then this is outside. This is outside. Um, this landing down here, you better check your code though. You check your code. Because don't be surprised if you've got a suppression team that's trying to get in this building. That's the fire department, dragging hoses and stuff, and they're trying to get up these stairs while people are trying to get out. Um, let's see. And we could talk about active shooter, but your special operations team's coming in here all armed to the teeth. Everybody's a suspect. Everybody coming down here screaming for their life could be the shooter. So then you get a big convolution, but that's for a whole nother discussion. All right, I shouldn't even mention it. I apologize. Door should swing in the direction of the egress. So this door is swinging out because this is where you want to go. All right. So these people on this floor trying to get out, so the door's got to swing in. Handrails. This is very important. Okay. Codes change over the years for handrails and guardrails. Let's go back over here to this one. A 4-inch sphere must not be able to pass through any opening in the railing from the floor up to 34 inches. You better check your current code. These things change. From 34 inches to 42 inches, the pattern may allow a sphere up to 8 inches in diameter to pass. Again, you better check your code, your local code, and your local ordinances. These have a tendency to change. As soon as one kid gets their head stuck in there or something happens and it makes the news, then they start making building code changes. These things need to be structural. They have a concentrated load applied non-concurrently to their top rails in both vertical and horizontal directions. You've got to consult your building code. They do nothing but specialize in putting in commercial stairwells in commercial buildings. And these handrails are generally cast in place with the concrete, and they stay abreast of the current code. Let's see. What do we got here? Handrails should extend at least 12 inches beyond the top of the riser and at least 12 inches plus 1 tread width beyond the bottom riser. Well, that's a rule of thumb. Again, your mileage is going to vary depending on your code and what your code allows you to do. I've seen fire stairs that don't have a handrail extension. They just wrap around and they go. So check your building code. The problem with extensions is if an extension out here, let's just say we've got an extension out here, it's a place for people to hang up when they're trying to get out in an emergency. So your building code may allow you to not do this, okay? Your building code. You may not need it. Treads and risers and nosings. A minimum of 3 risers per flight is recommended to prevent tripping and may be required by the building code. See the next page for detailed tread, riser, nosing requirements, etc., etc. All right, what is he talking about here? Remember what a riser is? Riser's the little r. That's this. That's the riser. This is your tread. The stair now becomes the tread. Okay. All right. So some codes require 3. 1, 2, 3. And why is that? It's human factors. You get them to running. You get too few of these, and you run into a potential tripping hazard. And that's what he's saying here. Check your code. Check your code. ADA as a whole access issues with stairs. No, you're not going to get a wheelchair person down a set of stairs. There's a special chair that you have to use. And you've got to be trained to use that chair. Accessible stairs should also serve as a means of egress during an emergency or lead to accessible area of refuge where people are unable to use stairs. May remain temporarily in safety to await assistance during emergency evacuation. As a building warden for the Cypress Center, if we have any ambulatory issue people in wheelchairs, I don't think we do this semester. We have in the past, and we've done our fire drills. Then we had a building warden sit with her on the upstairs portion. All right. And since the hydraulic elevator at the Cypress Center is periodically notorious for not working, we just moved her classroom downstairs for the entire semester. So during the fire drills, we didn't have to worry about it. But assuming she was on the second floor, then we would have to have a fire warden stand with her. The fire warden downstairs would notify the fire suppression team when they came in, that's the fire department, and let them know we've got a wheelchair victim upstairs. And they would then go up and pick her up and take her down. She had a motorized wheelchair, so that thing was pretty heavy. So we would have to put her in an evac chair, a specially designed chair, and they would carry her out. And then we'd get a couple of bull necks in to pick up her wheelchair and take it downstairs to her. But we didn't have any real fires. This is just all drills. All right. Handrails should be free of sharp and abrasive elements. Well, no kidding, okay? All right. This is what we're talking about, this 1.5 inches minimum, okay, to get the hand wrapped around the handrail, okay? That's the interior space. That's this interior space, okay? Now you got the thickness of this handrail out here, all right? So that's the 4 inches that we're talking about earlier, okay? All right. Handrail should be free of sharp objects sections with an outside diameter of 1¼ inches, a minimum, and a 2-inch maximum. We're talking about this diameter right here. So the diameter of the handrail needs to be anywhere from 1¼ inch to 2 inches. Talking about the diameter. All right, what is a nosing? A nosing is the edge treatment of the tread. Now we're using these terms. Now he goes back to risers and treads because the tread is the finished surface of your run. Okay, this would have been the poured concrete pan, and this is the run, the big R, and this is the little r. But once you finish it, now this becomes the tread. All right, because you're treading on it, right? So risers and runs. So if this is 11 inches, and this is a minimum of 4, then we have a ratio of what? 15 inches. That's outside of the ideal 18, but it's doable. It's accessible. Okay, let's see. A riser height and a 7-inch maximum. So if you had 11 and 7, then that's 18. Okay. But all this then affects the total run of your stair from here to here. And then if this is just an open floor, that's one thing. But if there's a landing, then you got to take that into consideration. There's several different ways to handle nosings. Residential houses, these are pre-manufactured, and you're buying the treads if they're wood, and they'll have a nose on them, and they'll hang out a little bit. Okay, and we will look at different kind of stair configurations later. The nosing, he defines the nosing with some dimensions: 1.5 inch maximum protrusion and 1/2 inch maximum radius. And the risers should be sloped, or the undersides of the nosing should have a 60-degree angle minimum from the horizontal. That would be here. It keeps you from having to hang your foot when you're climbing the stairs. Okay. These are really cool and work, and you'll see these in a lot of the cast in place concrete situations like this. See how that's done up here? All right, ramps. ADA has their own regulation for ramps. The slope of the ramp. The slope of the ramp is no different than the slope of a roof. The rise over the run. Okay. Maximum slope. That would be the rise over the run. Okay. Okay. And check your building codes and the ADA requirements. 30 inches maximum rise between landings. And then ADA, if I remember correctly, has a designation of where your landings need to be spaced. I mean, you don't want this thing to be like an amusement park ramp. All right. So ramp should have level landings at each end with a 60-inch minimum length. Landing should be as wide as the widest ramp leading to it. Well, that makes sense. All right. So a 60 by 60 minimum landing where ramp changes directions. In other words, if this ramp, if you're coming up here, and then you got another ramp here coming up, then you got to have a place for that wheelchair to turn around. All right. Handrails. Ramps having a rise greater than 6 inches or a run greater than 72 inches should have handrails along both sides. Handrail requirements are the same as for stairways. All right. That means the extension. Okay. And then there's a height. All right. Check your building code. Check the ADA code. Those things have a way of changing. All right. And it is not the regulatory agency's responsibility to let you as the designer know when these things change. And we're at 42 minutes. All right, let's talk about stair plans. That's probably a good idea for another video. So let's do chapter 9 to here.